Imagine the challenge of feeding astronauts on a long-term deep space mission, like to Mars. It's much more complex than just growing potatoes. A new paper in Acta Astronautica breaks down the entire food system necessary for survival in deep space, showing it's about much more than just growing crops. To truly succeed, a space food system needs to address 5 critical elements. These elements cover the entire cycle of providing sustenance for astronauts. The 5 elements are production, post-harvest management, waste management, preparation, and the socio-cultural aspects of consumption. If even one of these 5 elements fails, the entire system can collapse, putting the lives of the whole crew at risk of starvation. When it comes to production, the initial question is how much we should actually grow versus how much we should bring with us. There is a huge problem with weight. Packing everything needed for a 5-year Mars mission in advance would add a massive amount of weight, which could be utilized for other critical necessities. A crucial part of an efficient system is, quote, closing the loop. Organic matter from human waste must be a key input to the plant-growing cycle to create a sustainable, closed food system. Post-harvest management introduces challenges, particularly the pervasive radiation in deep space, which affects more than just human physiology. Radiation impacts food quality. Storing food for 5 years while constantly bombarded by radiation is a major hurdle for safety and edibility. Radiation can also mutate bacteria, making them more dangerous and harder to kill. Food poisoning could lead to life support system failures and mission disaster. The remaining elements focus on what happens after the harvest, managing waste and preparing the food for consumption. For a hydroponic system to be truly useful, its waste must be efficiently recycled by the life support system. Without this, the system is only sustainable for as long as new feedstocks last. Cooking in micro or low gravity is a challenge, as heat, fluids, and particles behave strangely. New systems and specialized astronaut training are essential for food preparation. The final element is the socio-cultural aspect of consumption, which addresses the psychological and nutritional needs of the astronauts. Managing crops and cooking offers a psychological boost for astronauts on long missions. However, this takes time away from other mission-critical tasks, requiring a careful trade-off. Menu fatigue is a real problem. If food lacks organoleptic appeal, taste, texture, and smell, astronauts are likely to eat less or simply dispose of it, leading to malnutrition. Malnutrition on a years-long deep space mission is a recipe for disaster. All 5 elements of the space food system must work perfectly to ensure the health and survival of the crew.